Hello, I am Susanne van der Feest. I am a research associate professor here at the Graduate Center. I came to the linguistics program at the end of 2018 after a decade at the University of Texas at Austin. And in the beginning of this year, I also joined the faculty at the Speech Language Hearing Sciences program. My lab is the Developmental Speech Perception Lab, which is located on the 7th floor of the Graduate Center. My main research interests are the acquisition of phonetics, phonology, and lexical representations of words in young children, but also in adults. I often work with typically developing children between the ages of 1 and 4. There are still so many things we do not know about typical development, and this knowledge is necessary if we want to be able to develop better clinical intervention programs for young children. I've also worked with children with hearing impairment and children and adults who stutter. I'm interested in both monolingual and multilingual development, and currently a large part of my research focuses on language variation. What happens when children are not just exposed to different languages, but to different accents in those languages, both non-native and native accents, such as regional dialects. This is in fact the reality for many children in the world. Most of the time, accent and dialectal variation is kind of ignored when we study language development. Especially monolingual children are usually treated as a homogeneous group, whereas in reality, they really are not. So an important topic I address in several of the current projects in my lab is what is the influence of language variability on young children's phonological development? Specifically, a relevant question in large cities such as New York. I work together on these questions with other researchers, for example, in Canada, Texas, and the Netherlands. The main method I use in my lab is eye tracking. The lab is still very young, and just a few months before the lockdown, we got a new portable iLink eye tracking system, which we are right now, of course, not able to use yet. Here you see a screenshot of the iLink software and some photos of the fixed setup, which I'll talk about more in a second. I've been using eye tracking in my work to study phonological development in children, but also phonetic and phonological representations of words in adults. And now I will show you a small example of what a very basic eye tracking word recognition study, or a so-called looking while listening paradigm, for 2-year-olds might look like. The clip you will see is taken from a study that is looking at the effects of different speaking styles on the speed and efficiency of word recognition. And the speaking style you will hear in the video is infant-directed speech.
I see something. Look at the cup. What do you see now?
And here you see an example of a 2-year-old Dutch learning child participating in such a study. He's my model example. I often show him at conferences and in class. He is here presented with subtle mispronunciations of familiar words to find out what he already knows about the sound structure of those words. The subtitles on this video are in Dutch, but I'll translate them for you. This child is particularly fun to watch because he's very engaged and pointing at the pictures. Children in these studies do not need to do that for us to get good data. So without knowing Dutch, you can see that some of the changes we made to the phonological features in the words are confusing him. They're hindering his word recognition. But some other phonological changes at this age, he really doesn't care about. Look at the ball. Do you like it? Yes, this was correctly pronounced. Where's the baby? Can you find it? There. And now he is getting a mispronunciation of place of articulation. He hears doll instead of ball, and this is confusing him. Can you find the bike? Do you like it? Yes. And now he is hearing a mispronunciation of voicing. So he's hearing a P instead of a B. And this, at this age, really doesn't trip him up. So that was one finding of this study. 24-month-old Dutch learning children don't care if you change the voicing in very specific ways, but they do care if you change the place of articulation of a word initial stop. Note that the boy that you just saw was tested without an actual eye tracker. It's also possible, and with very young children and a simple setup, sometimes just easier, to use a poor man's eye tracking setup. Participants simply sit in front of a large screen and eye movements are coded after the experiment by analyzing a close-up video of a participant frame by frame. I usually teach students, graduate and undergraduates, who I work with, at least the basics and idea of this methodology. So here you see an example of a graph showing coded eye tracking data. I'm more than happy to talk about this specific study with anyone who's interested, but for now it's just an illustration of what this kind of graph can look like. You see here on the x-axis time, and on the y-axis you see the proportion of the participants' total looking time that they spent fixating a named target object. So if the line goes up to 1, that means that 100% of the looks were to the target and no one was looking elsewhere on the screen. If it would be at -1, it means no one was looking at the target object. So you see that over time, after an object is named, the lines go up. People are looking at the named target picture. The 6 colored lines here are 6 different conditions. And in this study, we looked at 3 different speaking styles. Clear speech, which is what I'm doing right now in this video. Infant-directed speech, which has much more pitch variation and is even slower. And conversational speech, which is very fast, which is what you might do if you're talking face-to-face with somebody you know very well. So we combined those 3 different speaking styles with different semantic contexts, and we looked at the influence these different conditions had on the speed of word recognition. Let me now give you a small virtual tour of the lab. The first door here on the right is a waiting room for parents, which is shared space where participants can be welcomed and children can play or look at books and get comfortable, and where we can explain the procedure to the parents and have them sign consent forms. And right before the lockdown, we were in the middle of changing the covers of the couch, changing some furniture and some toys around, and we'll continue doing that as soon as we can go back to the GC. Here, just a few doors down the hall, you see the main room of the lab, where we have a fixed setup to use the iLink eye tracker or a large screen for hand-coded eye tracking if we prefer. This is a kid-friendly space when you come into the room, but we can also close these curtains halfway in the room so that children participating in an experiment are not distracted by anything in their surroundings. And behind the curtain, we can control the experiment and the eye tracker on a separate laptop. And we can observe the main testing room from the room next door, where we have a mirrored window that works so that you can see into the light, but not into the dark room. This is very convenient, so we can keep an eye on children and their parents or adult participants at all times without being in the same room and potentially being a distractor. In addition to speech perception experiments, we also do studies on speech production and database analyses. We use publicly available databases, mainly with the program FAWN. You see a screenshot here, to look at large samples of young children's early speech productions. And we also do acoustic analyses with Praat, which you can see in the screenshot on the right. Production studies can be done in the lab, and we have excellent recording equipment and sound booths at the Graduate Center. But conveniently, especially right now, many of these types of studies can also be done remotely. And you will now hear from a student who is currently finalizing her own production study.
Hello, I'm Evgenia. And right now I'm finishing my master's degree in linguistics and working on my thesis project that is dedicated to the production of the Russian vowels E and U by Russian English bilingual children. Initially, my plan was to do the eye tracking study, but my plans had to be changed due to COVID-19. However, Dr. van der Vest and I were able to change the project to production study. And we're able to design and collect the data over the summer. Using the Zoom and the iPhone, the parents of the participants were able to use their iPhone and record the experiment and send it to me for analysis. The data collection was successful and we were able to collect the data that we needed. And right now we are at the stage of the acoustic analysis of the data.
Apart from projects on speaking style and accent variation and database projects on early production, we are right now working on projects looking at word recognition in second language learners of English and also on phonetics and phonology of voicing in Korean. And this last project was set up by Priyanka Oghu, a senior undergraduate student from Brooklyn College, who also presented her ideas at the Speech Language Hearing Sciences Student Research Days last fall. And Priyanka is now at medical school. We're planning to continue data collection on this project as soon as this is safe again. We have lab meetings this semester every other week on Thursdays from 11 to 12:30. Anyone is welcome to join in and participate in the discussions or just listen in. If you are interested, please send me an email at svanderfeest@gc.cuny.edu. And you can also find more information about the lab at our website, speechperception.ws.gc.cuny.edu. You're always welcome, and we really hope to see each other and you in person as soon as possible. Thank you very much.